Hi guys, so let's continue our journey in binary numbers. So last time we see how we represent the numbers in decimal system. Then we compare that to the binary system, and we saw, or make a new system called binary system that we can, that the computer can understand. Okay, and we see how to convert from decimal to binary, and now we see from binary to decimal. But we didn't talk about fractional numbers, like in decimal, let's say 1.5. Okay, how to represent the fractional numbers in binary system as well. So to understand that, we're gonna see first how to present a fractional number or analyze a fractional number, a number that has some fraction in decimal system. Then we go and do the analogy to the binary system. So let's start first by the decimal numbers, and between brackets, numbers with fractions. And let's have an example, like for example 26.75. So here, okay, in the first lecture we see how to represent what actually 27 is composed of. It's 2 tens and 7 units, right? So let's move with the flow and see if this will go, if this will match what we have learned last time. So 26 is actually 2 tens, 2 multiplied by 10 to the power of 1 plus 6 units, which is 6 multiplied by 10 to the power of 0. How about we continue in same order? I mean, put the decimal point, then 7 multiplied by 10, and if you see the flow here, we have 1, then 0, then this will be minus 1. Then this is plus. I'm sorry, this is plus here. Plus, not point, plus. Then 5 multiplied by 10 to the power minus 2. Okay, now let's see if this flow of reduction was correct or not correct. Good, you just calculate what you have, and if you get back to 26.75, then you are right. Good, so this is 20. This is just 6. And what is this? 7 divided by 10, or 7 multiplied by 10 to the power of minus 1, which is 0.7. Plus, what is this? This is 5 divided by 100, or 5 multiplied by 10 to the power of minus 2, which is 0.05. Good. So if we add those up, this will give us 20 here, 26 here. And if we add this plus this will give us 0.75. If we add those two numbers together, this is 26.75. Good. So basically, decimal numbers, fractional numbers have the same flow, 10 to the power something. Okay, but these exponents are all negatives. Okay, we're gonna do the same, exactly the same in binary numbers. So let's have now binary, sorry, let's have another color. Binary. Let's go fractions. Binary fractions, okay? Or binary number with fractions. Let's have an example here, like this number, 11.01.01. Okay? Let's convert it. So this is binary number. So let's convert it to decimal. What we're gonna do? So this is here is the decimal point. Okay, so this is 2 to the power 0 to the power 1. So we have 1 multiplied by 2 to the power of 1, this guy. Then this guy here is 1 multiplied by 2 to the power of 0, then plus this guy, which is 0, and we continue the flow. So the exponent here is 1, the exponent here is 0, then minus 1, minus 2, and so on. So 0 multiplied by 2 to the power of minus 1 plus this guy, which is 1, multiplied by 2 to the power of minus 2. Okay, good. This is 2. This is 1 multiplied by 1, which is 1. This is 2 to the power of minus 1. It's actually half. And half is just 0.5. 1 over 2 is just 0.5, which is half. And what is 2 to the power minus 2? It's 1 over 4, which is a quarter, 0.25. Good. So 2 plus 1 is 3. And 0.5 plus 0.25 is 0.75. So this number is actually 3.75. So basically 1101 in binary is equivalent to 3.75 in decimal. Okay, so same stuff. Same stuff. Last time as well, we learned how to convert from binary to decimal, from decimal to binary, and from binary to decimal. We see here how to convert fractional numbers in binary to numbers in decimal. Now how to do the opposite, how to convert 3.75 to its representation in binary system. Let's do that. So we have two examples. We're gonna take first 3.75, then we have another longer example. So what we are doing here is that we deal first with fractional with integer part, this part I mean, then the fractional part. Okay, and for the integer part we will do the same as what we have done last time. So 3 we're gonna divide by 2, so this is number 1. 3 divided by 2 is actually 1, and the remainder is 1. So the quotient here, and here is the remainder. Okay, good. And we said that we stop when we reach 1. So we have reached 1 here. So 1 divided by 2, the quotient is 0, and the remainder is just 1. Okay, so 3, which is the first part, converted is what is converted to 1. So this is decimal here, and here is this is binary. Good. What is the second step, which is a new thing here? So the second step is to convert the fractional part, the 0.75. And here we do something opposite. We are not dividing, but we are multiplying by 2. Okay, and we stop when we reach a number that has no fraction. Let's see that. So first we multiplied the 0.75 by 2. So this will give us 1.5. Okay, let me check something here. 1, yeah, okay. And if you remember here, we were looking at the remainder, right? Here we are looking at these remainders. Here we will look at the integer part. Okay, so here the conversion will be in this integer part. So the integer part here will be either 1 or 0, as we will see now. Okay, so we get here 1. Then we take the fractional part and deal with it. So we take now the 0.5 and multiply it by 2. And this will give us what? This will give us just 1, which is written as 1.0 or 1.0. This is important here. So this one will be in the conversion as well, as we'll see right now. And now since we reached 0, then we stop. So what is now the fractional part? So the conversion is here. This is the conversion. So 0.75 in decimal is actually 1 1 in binary. And again, an important question, where is the most significant and least significant bit? So this is the most significant, and here is the least significant. I mean, this one here is actually this one, and this one here is actually this one. Okay, now we combine both. So 3.75 in decimal is actually is 11.11 in binary. Let's have another example, you know. So example, let's say that this is, for example, example 1. Let's say example 2. So in example 2, let's take, conversion or converting 0.6875. We want, you know, it's equivalent in binary. We'll do this here. Everything is decimal, so I'm sorry, fraction, so we'll just multiply. So 0.6875, we multiply by 2. So when we multiply this by 2, this will give us 1.3750. This 1.350, we will take the integer. So this is, you know, the most significant bit. And then we keep continuing with with the fractional part, which in that case 375. We multiply again by 2. When we multiply it by 2, this will give us 0.75. So here the integer part is just 0. Then we take the fractional part, which is 75, multiply again by 2. This will give us 1.5. So here the integer part is 1. And we take the fractional part, 0.5. We multiply by 2. This will give us 1.0. We take the decimal part. And since the fractional part is 0, we stop. Okay. So the conversion here is that, let's write this here. So the conversion here, remember this is the most significant bit. So this is 1, then 0, then 1, 0. Okay. So 0.6875 in decimal is can be represented as I'm sorry, this is point here, should be point 0.1011 in binary. Okay, let's check. Let's do another check. So let's convert this back. Okay, so this is 0 point, I'm sorry, plus 1 multiplied by 2 to the minus 1 plus 0 multiplied by 2 to the minus 2 plus 1 multiplied by 2 to the minus 4 plus 1 multiplied by 2 to the power, I'm sorry, 3 here, and then 4. Okay, then this is equal to 0 plus 1. 0, by the way, is that before the point, the binary point, not the decimal point. Okay, so 2 to the power minus 1 is actually half, plus this is quarter, 1/8, then 1/16. Okay, if you do it, let's do it together now. Let's, you know, have a calculator and do it. So let's open, you know, this online calculator. We have 2, 4, 8, 16. Okay, so 1 divided by 2. Let's bring this away. Then plus 1 divided by 4. Then 1 divided by 8. I'm sorry, this is wrong here. Yeah, plus, where is the plus? Yeah, 1 divided by 8. Then 1, I'm sorry, plus 1 divided by 16. Yes, this is multiplied by 0. Remember, we are converting back So this is multiplied by 1, and this is multiplied by 1. So yeah, 6875. Okay, guys. So we see now how to represent fractional numbers in both decimal and binary, and how we convert a fractional number or a number with fraction in general from decimal to binary and binary to decimal. Okay, so let's keep on this revision, and in the next let's say sub lecture, we're gonna see more of that revision on binary numbers.